I currently use the cloud myself for analytics at another startup, where I use mainly the Elk stack to ingest logs. In the process, though, I have to do a lot of configuration on AWS. So I'm certainly curious to know how this platform could help simplify what I do. Again, so welcome everybody to this month's Big Data Bellevue, and I'd like to turn it over to Jin to give our month's presentation.
Hello everybody, I'm so excited to present a new development paradigm, architecture as a service, that will increase on-demand provisioning ability. Before that, I'd like to briefly introduce Snapblocs and my team. My name is Jin Kim, and I'm a chief architect and one of the co-founder of Snapblocs. I have over 34 years of experience in enterprise-level software development, architecture and integration in telecommunication, social networking, and the manufacturing domain. I'm a certified enterprise architect and always looking for new platform technology to drive innovation. I work for several Fortune 500 companies like Boeing, AT&T, T-Mobile, as well as a startup and then medium-sized company as well. And we have Jonathan, who will lead the Q&A session. So Jonathan, could you introduce yourself briefly?
I look over the Indian operations of Snapblocs. In my passion, I really like the software architecture and the patterns and mainly the how we drive the automation. And I have worked on a lot of wide range of open source big data technology in the past. Yeah, I'm happy to answer any questions you have. Anybody has in the chat while Jin is presenting his talk. Yeah. Thanks, Jin.
Thanks, Jonathan. Okay. Snapblocs is an early-stage startup company founded by Paul Scanlon, CEO, Jonathan Goodrew, Jin Kim, myself. Snapblocs deliver a library of a no-code data platform solution in days instead of a month, based on the architecture service that integrate best-of-breed open source software. So today we'll talk about what is the architecture as a service and its benefit, and then how Snapblocs use architecture as a service to provide the better integration and development paradigm. And we'll have a live demo followed by a Q&A. Before start the talk, I'd like to ask you, what if you have to have a car with a customized car seat that fits you, either because you are too tall or too small? Whatever the reason, you have to have a customized car seat that fits you inside of your car. Do you want to build a car by yourself from scratch? Oh yeah, well, you can buy all the car parts and assemble the car by yourself. Sure, we can learn how to build a car. Some of us will be faster or slower at it. And some of us will make a minor mistake or serious consequence mistake. And some of us, like me, will never finish. We can Google for the help we need, but is it what we really want to do? Obviously, this is very inefficient, but inefficient or not, this is how technology teams are building data platform today. This reinvention wastes effort and increase the time to value. Data help us to operate and optimize, and more importantly, innovate. We all compete and survive in data-driven world, but data transformation projects are not easy, and the requirements are unique to each business. Serious constraints exist around skills, operational complexity, and the security. The business team wants IT, working on business goals and objective full time. In reality, IT teams spend most of their time laying out foundation. To improve efficiency and agility, IT development paradigm has been changed. Before the cloud, each company had its own data center. The evolution of cloud computing makes it easier to build application stack. Cloud computing starts with the notions of as a service, offering on-demand provisioning ability. This as a service model starts with the infrastructure as a service, like AWS EC2. Infrastructure as a service provide users with a cloud computing infrastructure. They need to perform either generalized or specialized tasks. Infrastructure as a service solution can be a pay-as-you-go storage, processing, networking, or virtualization, and so on. And then it slowly progresses into platform as a service like Heroku, Amazon Beanstalk, Google App Engine, etc. Platform as a service provides a platform on which a developer can design and deploy applications without getting involved in time-consuming routines like server and storage configuration, security, auto scaling, and load balancing, etc. And then what is the next after platform as a service? Snapblocs envision architecture as a service is the next layer. Then what is architecture as a service? Architecture as a service provides dedicated architecture blueprints to quickly build a data platform on demand using open source software by simply choosing the right architecture blueprints from the catalog of architecture blueprints for accelerating the build of business application solutions. Now, architecture is about the patterns, and the architecture pattern is a general, reusable solution to a common occurring problem in software development. The architecture pattern is automate the creation and the lifecycle management of computing resources with the common system concerns such as observability, auto scaling, security, etc. We will see the sample of architecture blueprint during the demo, but before that, we'd like to see some benefit out of it. Architecture as a service provides the configurable UI solution that eliminates coding, manual configuration for increasing speed, consistency, and reliability. And also, it allows the building software solution faster by choosing a suitable architecture from the well-designed architecture blueprints instead of designing and building the architecture from the scratch. It is easier to maintain software as the structure of a well-designed architecture is straightforward and easy to understand. As the software architecture creates a clear separation of concern, it helps us to quickly add new features of supporting new business requirements. And it makes it easy to replace all the implementation of software with new ones for improving SLA. It provides a more reliable assessment of system quality attributes like performance, security, observability, interoperability, reliability, ability, and scalability, and so on. It reduces the total cost of ownership with a faster time to release and the lower operational and maintenance cost. Architecture as a service should provide the customers with a cloud-native deployment platform for configuring, deploying, and managing data platform across Amazon AWS, Microsoft Azure, Google GCP, and other cloud providers. It also automates the buildings of custom data platform solutions. Companies do have a unique requirement, but in terms of the technology solutions, there are common patterns and use cases. These represent opportunity for automation. Therefore, architecture as a service should offer a library of common solutions that may be ready to go. This is how Snapblocs implement architecture as a service using the SaaS management UI, which is called the DP Studio. You can choose the architecture blueprint from the library and configure its component, and then deploy the stack on the Kubernetes cluster within the customer's cloud environment. You are able to configure and iterate advanced automation that support multi-cloud deployment on top of Kubernetes, the out-of-box, security, lifecycle management, and observability all provided. Snapblocs' visions of architecture as a service make us unique. Based on the architecture as a service concept, Snapblocs currently support 35 plus technical common use case to start. Then we'll go over them during the demo. So then it's time for demo. I will switch the screen to the web browsers. This demo shows how Snapblocs implement architecture as a service, and then you will see how you can build and manage the custom data platform without writing any infrastructure code. Even though you may be not familiar with the cloud computing or the Kubernetes, this demo maybe still help you to learn how to easily deploy and then the data platform application to a multi-cloud environment. So we don't build a data platform for the sake of a data platform. We build a data platform for building business application. So we'll see one of the very simple data ingestion application that ingests data from Google GCP to Amazon AWS. This sample application was built with data flow stacks, one of the platform Snapblocs provided, without writing any code. We'll come back to this sample application after we deploy the stack. Okay. So before we showing the detail, I'd like to show you a really quick rundown to deploy data platform stack in a cloud environment. To configure new stack, just click this configure new stack. The first step is to choose the cloud provider, and the next one is choose the architecture blueprint from the library, and the next, and then name the stack. So I say Bellevue Big Data Demo 1. So, and then click configure stack, and it shows the list of the component, and then we can configure the component using UI. And the last step is click the deploy. That doesn't look really complex, does it? So let's dive in. Okay. You need to register to Snapblocs for creating your free trial account. The Snapblocs doesn't store your login and credentials, so let me start creating a free trial account. Okay, so you need to create your free trial account. Snapblocs doesn't store your login and credential to Snapblocs database because Snapblocs delegate the registration and the login process to Amazon AWS Cognito, which is AWS user identity and the registration service. So your login information is safe and secure. I will skip the registration process by logging into my account directly. Okay. This is a TP Studio main dashboard showing the high level of view of your account environment. Shows number of stacks, the projects, the component, the node, cloud provider, and users. And also it shows the list of the stacks with a really summarized deploy stack. As you can see, there's two stacks running on. One is in the AWS, another one is GCP, the health status state as well. Normally when you want to work on your cloud environment, you need to ask your IT department for using your cloud account. But the Snapblocs provide a free sandbox credit so that you can freely deploy your stack to Snapblocs AWS sandbox environment. Therefore, you don't need to ask your IT department for using your cloud company cloud environment for deploying your stack during the free trial period. To claim the free AWS credit, you just click this button. And then you can book a demo, or you can have a live chat with the support team. And also you can get the online help documentations and the tutorial video and so on. Okay. Before showing the major feature, which is projects and stacks. I'd like to briefly go over some of the account setting so that we can go spend most of our time the most important feature. So we have user management, and also you can manage the fine-grained access control for each users using RBAC-based access control. You can define the policies and add the policy to role groups, and then add the role groups to user. This is typical RBAC-based authentication access control. And then one of the really important things I like to kind of point out that is to deploy your stack into a cloud account, you need to have a provide access key for the cloud account. Provide access key permit to the Snapblocs to access the cloud account for deploying and managing your stacks. So your free trial account comes with the default provide access key for the Snapblocs AWS sandbox. So you don't need to create your own new provide access key during your free trial period. But if you still want to deploy your stack into your own cloud environment, such as GCP or AWS or the cloud environment, you need to create and register your provide access key through this access key process. To create your provide access key, click Add, and select which where you want to create an access key. Click a cloud provider. For the AWS, we provide two different methods. IAM role, which is recommended by AWS. The IAM key is another method. And all this information can be found, detail about how to create, how to register, coming through this help documentation. There is also video. You can test your new provided key before save it. Okay. Snapblocs store your provide access key information at the secure AWS parameter store instead of the Snapblocs database. So your access credentials are secure and safe. So let me go into really important features of our Snapblocs. Snapblocs stack dashboard shows the old stack that has been created with the status and the summary. As you can see, some of them is not deployed, some of them is running. Those two are running. One is in the GCP and the other one is AWS. The project is a set of the stack grouped by the function or target environment for the stack management. Select the project where you want to create your new stack into. So this is a project, the main dashboard. Then the first steps to create the new stack is click configure new stack. Snapblocs currently support Amazon, AWS, and the Google GCP, and the Microsoft Azure support will be coming later. As your free account, click this AWS account, so you can deploy your stack into the sandbox account. The second step is choose the blueprint from the stacks. Here is how Snapblocs implement architecture as a service. Snapblocs provide the library of architecture platform blueprint. Snapblocs will add more blueprints as getting a request from the customer, such as a machine learning platform later on. This data platform. So you need to choose the platform blueprint that will serve the purpose of a stack, and each blueprint contains the several best-in-class open source components, and install them on Kubernetes and to deliver data platform solution. For example, data platform blueprint is for moving data from various input data sources to target data destination, either in a stream or bulk mode. So the stack created from this data flow blueprint can be used for data ingestion, data replication, or data synchronization use cases. Data flow stacks include Confluence Kafka for data streaming, and Elastic Stack and the Grafana for observability, and the stream set data collector for the data flow management. You will see how they work together soon when we see the data ingestion sample application. Snapblocs create AWS EKS Kubernetes first, and they install all the components on EKS cluster, and then it configures components so that those components can be securely interconnected through Kubernetes ingress with the secure TLS protocol. And also, each blueprint library comes with a lifecycle management such as start, update, terminate, pause, resume, clone, move, and the built-in observability features, and as well as a recommended best practice. We'll see them in detail soon. Snapblocs include the following prefabricated blueprint now that combines best-in-class open source technology. We already talked about the data flow. This is for data ingestion, data replication, data synchronization use cases. Data as a service is for simplifying data access and accelerating analytic processing with the Dremio, Elasticstack, and the Grafana. Data transformation blueprint is for converting data from one to another structure using Apache Spark, Airflow, and Elasticstack, and the Grafana. Data Lake blueprint is for enterprise data lake solution, including data ingestion, data transformation, and data analytic use cases. Microservice blueprint is for building a Microsoft application. It provides an API gateway, Kafka message bus, Istio service mesh, Kiali observability, and others. Also, we have several development platforms, including Kubernetes, Kafka, Elastic Stacks, StreamSet data collectors. All these plus platform, we add the huge additional value on top of the basic open source software. For example, we add the cost optimization, security, recommended best practices, and observability, and the full lifecycle management, and so on. Okay. You can find the detail about each platform, just following more info. You can see the detail about what is this data platform is for, and you can find the common use cases for each platform. And then you can find the detail about how to configure it. Now, okay, click Next. Once you select the data platform blueprint you want to use, and then you need to name Bellevue Data Demo 2. Okay, let's say this should be unique within your projects. Okay. The next step is you need to configure the stacks. We configured the stack, but we haven't deployed the stack yet. So stack dashboard shows the detail of the stack status. It shows not deployed. Since no resource exists before the deployment, so no statistic has been on the asset is showing everything is a 0. Status is not available. The next step, fourth step, is to configure component on the stack. So we need to configure each component before deploying the stacks. You can configure the component without writing any single lines of code, such as YAML, Terraform, JSON, CloudFormation, or any other program language. So let's do one by one. Most stacks component comes with a reasonable default value, so that you don't need to make many changes. So for example, select AWS and Kubernetes. The first one you need to select provide access key. Your free trial account, you select the access key provided by your free trial account. This enables you to deploy your stack to the Snapblocs AWS sandbox environment. Or you can choose to select your own access key for your cloud account created through the provide access key process we saw earlier. So I will select my provide access key. select the region. For the free trial, we provide only 2 regions. However, if you select your own key access key, you will get the full list of the regions covering the entire world. So I will select my US West 2, select the VPC, and it shows the list of the subnet under the VPC. And then you can actually define the API endpoint, whether it's public or private. And also you can define the CEDAR range to access your cluster. And also you can customize your Kubernetes cluster, such as the desired and the minimum and maximum size and the volume size. And you can choose the Kubernetes version, or you can select the instance type. And then also there is several other configurations, whether you want to enable the SSH to access the Kubernetes, or you can also add a bootstrap to the worker node. So once you finish the setting, save the setting. And the next one is Kafka. So remember, we are configuring data flow blueprint, which is for data ingestion, replication, and synchronization, which we use a Kafka provide the data messaging service. So the Kafka comes with all reasonable default values, so you don't need to make any changes to deploy it. But if you want, you can choose different Kafka version. And also you can set the broker or replica, which is set to 3 as a default, and the storage size, and you can set the memory and then a CPU setting. And you can set the zookeeper setting. You can set the KSQL server setting. You can set the Kafka Connect server, schema registries, Kafka UI topic, and so on. Because every value looks reasonable for deploy, so I will not make any changes, so I will cancel out. The Elastic Stack also comes with all reasonable default values, so we don't need to make changes, but if you want, you can choose different Elastic Stack version. This is something we add. Open source, so Elasticsearch doesn't come with the login panel for the Kibana, but we added that authentication to make the Kibana secure. So you can set the password of the login pages. Then you can set the CPU memory configuration, and the storage and the setting configuration for Logstash, Kibana, FileBit, Matrix bit, and so on. So I don't want to make any changes for deploying it, so I will cancel out. Other one, Grafana, it's also same story. All the configuration comes with the regional value, so I don't need to make changes for now. And the same as a stream set data collector. Okay, so just to make the few changes as needed through the UI configuration, and then now it's time to deploy. It shows the kind of summary of your configuration providers, and then provide access key, and then Kubernetes versions, and the VPC, and so on. So let's say looks like everything looks okay, so I deploy. So deployment takes sometimes about 20 to 30 minutes. So to save the demo time before the presentation starts, I deployed the data flow stack twice, one in AWS and another one in GCP. Okay. So let me take a look at the pre-started. Okay, let me select the one, this one. This one is already deployed. Okay. As you can see, this stack is on deployed status, and the status shows healthy, and you can see the CPU and the memory statistics, and you can see the asset created, 5 component and 58 pod and 1 load and balancer, and then 6 worker node is running. And it also shows the individual component status is healthy, and the number of a pod has been created. And you can see the worker node statistics, and also you can get the detail of each node. And you can see the Kubernetes volumes created for these stacks. And then this is the log for entire log for this the stack creation. So as you can see, it creates a lot of resources to create these stacks for data flow blueprint. It's about 200 resources in the right order for these stacks. Imagine that you create 200 resources with the correct sequential order by yourself using either Terraform or CloudFormation. It really takes a lot of infrastructure coding and it takes a lot of times. As you can see, Snapblocs implement architecture as a service by providing the UI template that eliminate the manual infrastructure coding, and it will increase the development velocity and decrease the human errors. Okay, and also, if you want to access Kubernetes cluster over these stacks, using a Kubernetes tool like a kubectl, you can also download the kubeconfig YAML file, and then you can full access to your Kubernetes clusters. I will show you the very unique lifecycle management feature Snapblocs provide following architecture service concept, the path and the region stack. Okay. After stack is deployed, you can pass the stacks. Once the stack is in passed state, all Kubernetes worker node will be terminated. It becomes a zero worker node, except for EKS control plane. These Kubernetes storage volumes and the stack configuration will remain, so no data will be lost during the passed state. When a stack is resumed, those volumes will be reattached to newly created Kubernetes pod. So for the stacks that you don't need the 24/7 uptime, for example, a development or the QA or staging environment, you could save computing time cost by terminating all EC2 worker node instance using the pod and then resume features. Another set is a clone and then move stacks. Once a stack is configured for one project, an authorized user can easily clone or move the stack configuration to a different project, then update some configurations such as a cluster node size or CPU memory setting or target environment setting through UI. Using clone and move the features, you can easily and safely deploy the stack to different environments like a staging or production environment. And then also you can change almost any settings configuration while the stack is running. For example, you can increase the Kubernetes capacity to higher capacity and the minimum maximum. You can apply those changes to running stacks. And also, you can change the Kubernetes versions or Kafka version too by simply changing the configuration on UI and redeploy. It doesn't shut down or nor pass the running stack while deploying those changes. With these live update features, you can have a fast, iterative agile environment. You can start with a small stack size for POC or development and update the configuration for increasing your application the load. Up to now, we saw how to deploy stacks. Now we'll examine the data ingestion sample application we saw at the beginning. That was created without writing any application code. Okay, let me go back to the main dashboard. The data flow stack comes with 5 components. These 5 components that are installed in the EKS Kubernetes clusters. You can access each component UI through provisioned application. For example, stream set data collector. Okay. This allows to creating data pipeline without writing application code. So I created 2 data pipelines before the demo. the producer pipelines, this one read sample transaction credit card information from GitHub, and then passing to next process, which is writing into Kafka cluster, which is installed in the Kubernetes cluster. And the consumer data pipeline read the credit card transaction from the Kafka brokers and do some kind of data mangling, such as for the data credit card number, obfuscate except the last 4 digits. And then after that, you're writing into S3 and then writing into Elasticsearch index. All components of the Kubernetes cluster are communicating with the secure TLS and the secure token authentication. For example, this Elasticsearch, when you talk streams data collector, when you're talking to Elasticsearch, you use HTTPS and the plus authentication token credential using the key store. With the streams data collector, you can connect to more than 100 source and destination data system, including a database or SaaS application or the big data, MongoDB, Cassandra. Also, you can make the very complex data pipeline application. And it shows kind of live the dashboard so that you can see observe the system behavior. The Snapblocs add the Apache NiFi for the data pipeline management as well soon. So you have a choice, either use a streamset data collector or NiFi data ingestion pipeline to create the data pipeline without writing any manual hand code. So also you can access the Kubernetes dashboard. To do that, you need to get the access token. Copy that, and then access the Kubernetes dashboard. Okay, and then you say copy the access token. Snapblocs create individual Kubernetes namespace for each component, following the best practice. So you can see the ingress namespace, Kafka, monitoring for the observability stream set. For example, if you click the Kafka namespace, you will see all metrics and resources created for the Kafka namespace only. Another one is a Kibana dashboard. The Kibana dashboard is already, every component is integrated in the Kubernetes so that we can access them securely. So we Snapblocs add several dashboards for the observability. For example, we add the system observability to see the state of the system. Each node, we have a 6 node and average CPU, average memory usage, disk usage, inbound, outbound traffics. And then each node, CPU and the memory, and also histogram by the CPU usage. And also, we add another dashboard for the Kubernetes. You can see the number of nodes and the deployment, and then pods, each pod, the configuration, the metrics, and the number of pod, and the statics of each CPU. And many of the metrics you can observe through this dashboard we added as observability, built-in observability. And also we add several other ones, but I would just want to start with this one more additional one, Kafka. So you can see number of topic, broker, partition, and replica. Then you can see the lagging, consumer lagging, and then offset as well. And then Grafana, we already integrate Grafana connecting to the Elasticsearch with the secure TLS connection. So those two, the file and the matrix bit is already configured, connected through the secure channel. So Grafana is connecting to Elasticsearch so that you can create alert based on any the behavior like to monitor it. And also, lastly, I like to just don't want to spend too much time, but the Kafka topic UI. Also, we add the transaction. I mean, this is the Kafka topics. We're sending credit card information so that you can examine the Kafka messages in table format or raw data format. Okay. So, as I said before, I deployed the exact same data ingestion application on the GCP. Okay, so this is running on GCP as you see. The other one is running on AWS. It's exactly same data ingestion application. There's a kind of a timeout, so let me refresh. Into this one. So they are ingesting 600,000 the message they already processed, writing it. So all Kubernetes and the component and processing are running on Google GCP for these stacks. But the sample application also saves the data into Amazon S3 so that you can achieve the data replication from GCP cloud to AWS cloud without writing any single lines of code. Just everything is UI driven, UI configuration, and also you can create the data pipeline through the either StreamSet data collector or an i5, which we'll be adding later on. Okay, after all this, if you want to stop the stack, you need to tear down. To tear down, you can have an option whether you can delete the Kubernetes volumes or you can keep it. So let me just delete the volume and then tear down. This process takes time. Once the process is complete, all node and 200 resources will be terminated in the right order, and the dashboard will be updated automatically. So now you saw how to deploy the stack in multi-cloud environment that manage your data platform using Snapblocs. I hope you see the benefit of architecture as a service, the how to use Snapblocs providing the library of a no-code data platform solution based on the architecture as a service that integrate the best breed open source software. So again, so we're trying to provide the more common use architecture blueprints. We'll keep adding more as we get requests from the community or the customer. So this will be ongoing the effort. So demo will be about done. So I'd like to have a Q&A session. So do we have any questions on architecture as a service or any implementation?
So, I mean, certainly other folks can jump in, but I had a couple questions. One thing I wanted to know, so with the blueprint that you had up last, you have like several components, AWS, Kafka, Elastic, Grafana. What if I don't need some of them? Like if I don't use Grafana, then that I can just say that's zero?
Jonathan, could you answer it?
Yeah, that's a very good question, Sid. So we have an option that is coming very soon in the roadmap to enable and disable components. So that is coming in the roadmap, I would say, so that you can disable Grafana and kind of use other components. And if you want to use other components, maybe just Elastic. Right now we have also, I think there is a workaround where you can have. We also have a la carte blueprint, so where you can just have a Elastic a blueprint involved in that.
So actually, this was kind of leading to my next question, which is, as a customer, can I create my own blueprint?
That's a very, very good question. Yes, so that is our product currently is called DP Studio. So we have in the roadmap a new product called DP Designer. So where we would like to completely have a customer kind of pick and choose, design their components. So we kind of provide some abstract level of APIs, and the customer can completely design their blueprint. That is, I think the DP Designer is much far ahead in the roadmap. If there is interest, we can kind of look into it. So that's the product 2 of Snapblocs we are thinking, as you mentioned.
Yeah, I mean, I certainly see value in, your centralized framework to manage, see, control, pause, and so forth. But, as far as building my own blueprint, I would suggest maybe as a future enhancement is the ability to possibly read an existing deployment on AWS and build a blueprint from that. So I could kind of give you a starting point and say, here's what I have, and you kind of reverse engineer it, break it out, build a blueprint, and then I can fine tune it or control it from there.
Okay.
That is excellent.
Yeah.
So in other words, what I understand is you have a system running on AWS with a native AWS service or not, or any other software you are running it. So reverse engineering your existing system to fit into our architecture service blueprint, so that maybe not 100% fully automate, but kind of give a really good way you can reduce the manual configuration or tweaking it, but you still take advantage of everything running on the one Kubernetes cluster combined together, and then they're connected through the TLS, which is safe, and provide also the pass and resume or the advanced life cycle, and also observability built it in. That I think, okay, that is a really good suggestion. Yeah. So currently we show most of the data platform blueprint, but this architecture service is not really limited to data blueprints. It can be in the future client UI side architecture as a service. So the client stack is also really complex, such as Ember or the JavaScript or the React form. How did they actually bundle together as one of the architecture service? That could be another way we can expanding out, not only for the data platform. Well, it can be used as a machine learning or any other way. We use a common use case over and over, that we can define the common set of the architecture that can be reused for multiple use cases with few the configuration changes.
Yeah, there are a lot of good questions in the chat. I'm trying to respond here.
Okay.
Yeah, one of the question came up is how do we compare with OpenShift? How do we compare with how we are different from OpenShift?
Okay, I see.
Yeah.
Could you?
So OpenShift.
Yeah. Could you explain how we are differentiated?
Yeah, OpenShift is just a Kubernetes managed platform. In order to build still this well-architected solution, it takes a ton of time and effort and choosing the components, configuring. So all these kind of things, OpenShift doesn't support them. And all our Snapblock blueprints are well-architected, and the components are added with ton of value like security, cost, and storage optimization, observability, best practices. And so our focus is on the components and the value coming from the components.
Okay, thanks.
Another question is this declarative like Terraform? I think our whole idea is to have a no-code platform, and having an ability to deploy a stack in days rather than months. So we don't. Yeah. So that's the whole idea of Snapblocs here. So Jin, I think there was another good question from Jishnath. Are the components mainly compute?
Oh yeah, okay. So The component can be any one, such as accessing data, such as a Dremio, data as we have a data as a service with the Dremio, or it could be Presto, which means allowing the customer to access multi-different data sources through the one SQL interface, and then it has built-in the cache and so on. So the component can be part of the entire platform solutions, but yeah, some of the component can be such as Spark SQL is a compute, or some other one compute. But depending on the blueprint component, the component can be the SQL access or the runtime compute, or it could be data pipeline construction. So yeah, based on the architecture blueprint, component could be mixed.
And we also have a microservices blueprint coming soon, where the customer can completely configure their artifacts and completely kind of automate the deployment of microservice. It comes with auto scaling, it comes with service mesh and Kiali and a lot of other good observability things. So another question, what kind of transactions per second can this support?
Yeah, so actually I can take it. Yeah, so this is depending on your cluster. So Kubernetes clusters. So Kubernetes is basically allows you can scale out, so that if you like to increase the transaction for particular data bus, for example, then you can have a higher the partition of the Kafka. So you can configure Kafka broker having multiple broker node, and then also you can have a higher number of a partition. Or if you want to increase a transaction for the data handling, for example, then you can increase the transaction or the size of the cluster of the either NiFi, which you can have a multiple parallel processing. So it's based on your transaction you like to scale, so that based on the size of the Kubernetes you can control. So you can maybe start with a really small size, and then you can tweak through the UI to increase how you can actually push your data through each part of the transaction. But the basic one, the minimum set I just showed, that was actually I can show you this is a sample one. Okay, another one is I processed 600 runtime transaction second is 150 per second with this small size of the cluster, which is running Kafka, Streamset, Elasticstack, and the Grafana, and all other components running on 6 node. So if you want to increase the throughput, and then you can adjust the total cluster Kubernetes size, and also adjust the other component as well too. So what I'm saying is that scalability will be depending on the size.
Yeah, another question from Jish. I have used both Kibana and Grafana and wasn't quite impressed with either of these. Can I access the data via API and create my own dashboard using my own tooling?
All the components will be accessible outside of the Kubernetes. Okay, so for example, you can access Elastic search so that you can get the data out of the Elasticsearch if you want to build your own dashboard with your own toolset. And another one is if you like to use a Datadog, I mean, that is a translation from any observability metrics we can ship to the Datadog if you like to use a commercial one. So at this point, we're trying to emphasize on focusing on open source first, but the integration between the open source to Datadog or the commercial one, that is just a matter of the connector where we want to send the data to.
And actually for the Kafka component, we actually expose the broker for the customer to kind of integrate them into their client applications outside of the Kubernetes. Similarly, for Grafana and Kibana, if the customer has a requirement, we can expose the API layer outside of the Kubernetes cluster to build your own things. It should be very simple for us. One question: how do I try this product? So the Jin said it's completely free, and as Jin pointed out, we don't need your cloud credentials. We don't need your company to set up a AWS account or GCP account to try this out. So we give a concept called sandbox. So you can claim the sandbox once you register, and you have a lot of time to explore and try this product out. Yeah. So another question: does it come with sample payloads or data sets or message brokers? So we, Jin, you can add me to my answer, but so we have a tutorial on the website with a video, and we have put some of the JSON files where you can download and kick it off after you have deployed the stack, so you can see the action in live. And in regards to message brokers, all the message brokers are, once you spin up a data flow or a Kafka a la carte blueprint, the message brokers. There is a column called provisioned applications. You can view the message brokers in there, and you can use it. You can do whatever required things you want to. And if there is right now, I think we are planning to set that up.
Currently, we have the support live chat with the support, or you can actually send email, or you can send any questions. So, and also show you the documentation based on your questions. So you can use our support live chat button on the site until we create a Slack channel.
Okay. Yes, I'd like to thank you, Jin and Janardhan, for hosting all the questions and this presentation, and wish you guys best of luck in rolling this out.